So this video is going to be all about how do you find percent composition of a compound. Well, it's really simple. Anytime that you are working with a percentage, percentages are always going to be some part, some portion of what you're dealing with over the whole thing, and then multiply this fraction by 100%. And so in this case, our part is going to be the mass of an individual element. And the whole thing is going to be the mass of the compound. And then, of course, we still multiply that by 100. And that gives us the percent composition of a particular element in a compound. So, what is the percentage of hydrogen in water? Well, we know that hydrogen has a mass of 1.01, and we've already figured out, we already know that water has a mass of 18.02. Well, to figure out the percent composition of hydrogen, we're going to take the mass of the element. So in this case, each hydrogen is 1.01 grams, but don't forget that we have two of those hydrogens. So we're going to take 2 times the mass of the hydrogen, 1.01, divided by the mass of the water, and then we're going to multiply that by 100. And so that works out to, I think it's like 11%. Hang on, let's pull up the calculator, shall we? So I know that 2 times 1.01 is 2.02, divided by 18.02 equals. And then multiply that by 100, or you can just simply move the decimal, and you get 11.2. And so that equals 11.2% hydrogen. How about another example? Yay! Determine the percentage of each element in H2SO4. So we have H2SO4. This is sulfuric acid. Something that starts with a hydrogen is going to be an acid. So figure out, the first thing that we need to know is the overall mass of this compound. And so we're going to take 2 times the mass of hydrogen, which is 1.01, plus the mass of sulfur, which is 32 point, I think it's 0607. Here's my periodic table. 32.07. Sorry about that little pause there. Plus, we have 4 oxygens, so 4 times the mass of oxygen, which is 16, and that's going to be equal to, use my calculator, 2.02 plus 32.07 plus 4 times 16, that's 64, equals, so we get 98.09. And the units on that are going to be grams per mole. Or if we were talking about an individual molecule of sulfuric acid, then that would be AMUs. So now to figure out the percent of each element, so we're going to do percentage of hydrogen first because it comes first in the compound. And so that's going to be equal to the mass of hydrogen, so 2 times 1.01 divided by 98.09, and then we're going to take this whole thing and multiply it by 100. And I'm going to get this all set up and then plug it into the calculator all at once. So the percentage of sulfur is going to be the mass of sulfur, so 32.07 divided by 98.09, and then multiply this guy by 100. And then for the percentage of oxygen, oxygen is going to be 4 times 16. You can get really good at multiples of 16 in this class, by the way. And I'm just going to go ahead and put 64 because that is 4 times 16. And that is going to be divided by 98.09. And multiply this guy by 100. And now I'm going to bust out my calculator. Get all this stuff out of the way. Yeah, guess where I'm at. And it is Wednesday, October 24th, 2012. Sorry, that's kind of lame. Okay, so we've got 2.02 divided by 98.09 equals, I'm just going to move my decimal, so I see that I've got move the decimal twice, so 2.059. Well, I'm allowed 3 sig figs, so I'm going to go 2.06 on this one. And then for my sulfur, 32.07 divided by 98.09 equals, and then move that decimal 2 times, so 1, 2, and I get 32.6944. Well, I'm allowed 4 sig figs on this one, so I'm going to do 32.69%. And then finally for our oxygen, 64 divided by 98.09 equals. Move that decimal 2 times, 1, 2, and we get 65. We're allowed 4 sig figs, so 65.2. We got 4 6, so this 4 is going to become a 5, so 65.25. Now, because we are working with percentages here, we know that when we add up the percentages of all of the parts, they should add up to 100. So I'm just going to do that and check my math real quick. So 2.06 plus 32.69 plus 65.25 equals, and I get exactly 100. So I know that my math is right. And if you want to see more examples of how to do percent composition, watch part 2.